Parallel lines and triangles. The parallel postulate states that if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. What that means is if I give you this line here and some point that's not on the line, and I asked you to draw a line through that point, but it has to be parallel to this one, there is only one line that can be drawn. So other than that green one, there's no other line that exists that can be parallel to the black one and go through that point. The triangle angle sum theorem. This says that the sum of the measures of the angles of a triangle is 180 degrees. Now, that means that in any triangle, the measure of one angle plus the measure of the other angle and plus the measure of the third one will always be equal to 180 degrees. Now there is a way to use the parallel postulate that we just talked about and the idea of alternate interior angles to prove that the three angle measures of a triangle have to equal 180 degrees. We'll talk about that proof in class. Now let's work through a few examples using the triangle angle sum theorem we just talked about. So it tells us that the three angles of a triangle have to add up to 180. So here we have one angle that's 31, another one that's 66, and another one labeled x. And we know that all three of them have to add up to 180. So when we're solving this equation, the first thing we want to do is combine like terms over here. So 31 plus 66 is going to give us 97. Then plus x equals 180. And then to isolate the variable, we want to subtract 97 from both sides so that we have x equal to 83. Now let's take a look at the second one. In example 2, you should notice here that we have this right angle. So don't forget, right angles are always 90 degrees, if you need to remind yourself. We have this angle labeled x and this angle labeled 8x. So it's okay that we have two different angles with variables. We're going to work with them the same. That angle that's a right angle plus the angle labeled x plus the angle labeled 8x, and all together it's 180 degrees. So again, to solve for x, first we want to combine like terms. The x plus 8x gives us 9x equal to 180. And then to isolate x, first we want to subtract 90 from both sides. And then we have 9x is equal to 90. And then lastly, divide both sides by 9. And then we get x is equal to 10. So our answer here is going to be 10. And I forgot to write the first answer to example 1 right there. Now let's take a look at example 3. I know it looks a little complicated at first because we have two triangles that are adjacent to each other, but let's just analyze what we have. In this first triangle on the left, we have this angle 64, this is y, and this is z. Now, because we have two unknown variables inside this triangle, we can't actually solve for them right now because we could find so many different combinations of y and z that can add up with 64 to make 180. So let's focus on the triangle on the right. So if we just focus on this triangle right now, then you'll notice that one of the angles is 28, one of them is 39, and the other one is x. So since we're only missing one angle, we can solve for that. 28 plus 39 plus x equals 180. Then we want to isolate the variable. So first, again, combine like terms. 28 plus 39 is 67. And then we want x by itself. So we want to subtract 67 from both sides. Then we get x is equal to 113. So we have one of our answers so far, and this x is going to be 113. Now, we still don't know y or z, but look at what happens here. Back in Unit 1, we talked about what happens when two angles line up right next to each other, they're adjacent, and they make a line. Those are called a linear pair. And linear pairs are supplementary. So, if they're supposed to add up to 180, and we know one of them is 113, then if we subtract it, we get 67 as the answer for angle y. Now that we have angle y, we can use that to help us in the triangle. So now we can shift gears over to this triangle on the left. And since we know one angle is 64, the other angle is 67, and then all we need to find is z. Again, the three angles add up to equal 180. So first we want to combine like terms. 64 plus 67 is 131, plus z equals 180. And then we want to subtract 131 from both sides. So we're left with z equal to 49. And now we found our last answer. So that's how we're going to use the triangle angle sum theorem to find the measures of unknown angles and unknown variables. Next, we want to talk about the exterior angle theorem. It states that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So I know this is a lot of words up here, so let's take a look at this triangle. We have our triangle ABC, but if you see this side that extends past the vertex of the triangle, and then what happens is it creates this exterior angle. So we're talking about this exterior angle, the measure of angle 1. Now it says it's equal to the sum, which is addition, of the two non-adjacent interior angles. So we have three interior angles of a triangle, but this angle C is adjacent to angle 1. We don't want that one. We want the ones that are not adjacent. So that means angle A and angle B. So if you add the measure of angle A plus angle B, then that'll give you the measure of angle 1. And again, we can talk about why this is true in class. So let's work out a few examples using the exterior angle theorem. So again, here we have the angle that's on the outside, and that's going to be equal to the sum of the two non-adjacent angles. So again, we have that 102, the exterior angle, and that's equal to not the one next to it, but the other two angles added together. So that's x plus 68. So now, when we want to find x, we just have to subtract 68 from both sides. That cancels out, and we're left with 34 is equal to x, and that'll be our answer. Now in the second one, it's the same idea, okay? Here is our exterior angle, which is x, and then it's going to be equal to the two angles, not the one right next to it, but the other two. So this one, x is going to be equal to the 90-degree angle plus the other one. So this, x is already isolated, so all we need to do is just add these two to simplify. X is equal to 124. Now lastly, let's look at this one. So same idea, exterior angle, not the one next to it, but the other two angles have to be added up. So we have 3x equal to 2x plus 30. So it doesn't matter if you have extra variables, as long as they're the same one, they're both x, then we're able to set it up. And then we just want to solve for x. Remember, when we want to combine these two x's but they're on opposite sides, we just want to subtract from both sides so that this side cancels, and then here we have 3x minus 2x, which is 1x, and that's equal to 30. So our final answer here is 30. Okay? Now, I don't want you to be overwhelmed, but I do want you to pause and try to use the triangle angle sum theorem to find the missing angle measures. So pause, draw this out, and try to work out the measures of each angle, knowing what you know, and then check back with me and we'll walk through it together. So you always want to start off in triangles that have the most information. So in this first triangle, we have 40 degrees, 90 degrees, and we only need to find one angle. So remember, that's 40 plus 90 plus angle 1 equal to 180. So this is 130 plus angle 1 equals 180, and then angle 1 is equal to 50 degrees. Now, this right angle and angle 2, they're vertical. They're opposite from each other with two intersecting lines. So angle 2 is also 90 degrees. Now we run into this triangle here, and we have 90 degrees plus 30 degrees plus angle 3. So 90 plus 30 plus angle 3 equals 180. 90 and 30 is 120 plus angle 3 equals 180. So when you subtract 120 from both sides, angle 3 is equal to 60 degrees. And again, this angle 3 and angle 4 are vertical, so that means they are congruent. So this is also going to be 60 degrees. Then when we move into this triangle, we have 60, 60, and angle 5. So 60 plus 60 plus angle 5 is equal to 180. 60 plus 60 is 120 plus angle 5 equal to 180. So when we subtract 120, we get angle 5 is equal to 60 degrees. And then again, we have angle 5 and angle 6 are vertical angles, and we know those are congruent. So angle 6 is also 60 degrees. And then lastly, in this very last triangle, we have one angle is 60, one angle is 20, and then plus angle 7 equals 180. So 60 plus 20 is 80, plus angle 7 equals 180. When you subtract 80 from both sides, we get angle 7 equals 100. And now we're finished. So you don't need to get overwhelmed when you see a problem like this, and don't be surprised when you see them. Just take it one triangle at a time, and then we'll also use concepts we've learned before about vertical angles. And even though it wasn't on this one, we did some example problems today using the idea of linear pairs. So don't forget about those. Okay, that's it for this set of notes.